Welcome. Yesterday we talked about what is a derivative. Okay, so is this one recorded? Yes. Yesterday we talked about what is a derivative. So recapping this a little, what is a derivative? If you have a function here, let's say this kind of function, then the slope of the tangent line at any point, let's say at this particular point, is the derivative. Okay, so let's say this is the tangent line. So slope of the tangent line at any particular point of the function is what? The derivative or slope. So slope in other words is the derivative. Okay? Slope in other words is the derivative. This is what derivative is, and you also define what a tangent line is. The tangent line is not something that touches the curve at only one point. It is not something, it can touch the curve at many points. It can cross the curve at many points as well in some cases, but in most of the cases you are fine with that. I mean, it cuts or crosses the curve at only one point. I mean, in most of the cases that concept will work, but still the tangent line is not that. What is the tangent line? Tangent line is the limit of the secant lines. Secant lines there. Okay, so you draw a bunch of secant lines, and the limit of the secant line at any particular point is the tangent line. We already talked about that, and yeah, it means that near that point the tangent line touches at only one point. This is what you can say. So near this point the tangent line is touching at only one point. Okay, so this is what derivative is. The slope of the tangent line is the derivative. Let me write it here. Slope of the tangent line at okay, so I'm gonna write this up. Particular point. At a particular point. This is what a derivative is. Now the thing is how to compute it, because it's not like, I mean, that we drew all the time the tangent to a point and then calculate the slope. I mean, it is not like that. There has to be a numerical way. There has to be a way to calculate derivative. So now I'm going to talk about the formula for derivative. Formula for derivative. Derivative. Okay. So how to calculate the formula for derivative. Now, one more thing. We know that tangent line is the limit of the secant lines. So let's say this is the curve. Then we draw, okay, let's say we want to find the derivative at this point, meaning the slope at this point. Then let's say we draw a bunch of secant lines there, which go with, I mean, this point Q, and this is getting closer and closer to this point. Does that make sense? So you're gonna have a tangent line there, like this, and slope of the tangent line is the derivative. Okay, and now first of all, what is the equation of the tangent line? It's nothing but it is y minus y naught times, equal to m times x minus x naught. So x is given a point. So this is the equation given a point, a particular point which lies on the tangent line. So the point is x naught, y naught, which is lying on that line. Okay, we know that. This formula can also be used for secant lines as well. If you know the slope of the secant line, you can plug it in and find what? Find the equation of the secant lines as well. What I was saying, that this formula can be used
for finding the equation
of the secant lines as well. So what differentiate the secant line and the tangent line, because is this m only, this m is here, and this m differentiates that, because it also passes through this point that we are concerned with. I mean, all those secants and also the tangent is passing through this point that we are concerned with, but what differentiates them is the slope. It is the m is the thing that is differentiating this. Meaning, how do you calculate the m of the tangent line? Meaning, okay, so we can say what? That the slope of the tangent line is the limit of the slopes of the secant lines. As you can see here, okay, so this is delta y and this is delta x. This is delta y. I should not complicate it with this. Actually, I should go directly to the point. We have seen that the slopes of these secant line, I mean limit of the slopes of the secant line is what? Again, the slope of the tangent line. This is the concept, because the tangent line is the limit of the secant line. In the same way, the slope of the tangent line is the limit of the slopes of the secant lines. Okay, now let's talk about the formula of a derivative now of the tangent, meaning the derivative is the slope of the tangent line. So let's talk about the formula of a derivative. Let's say the same function, the same kind of function. Okay, the curve is supposed like this. Okay, this is x, this is y, and okay, let's say that we're gonna find the derivative at this point, and a secant line there is just like this. A secant line is like this. Okay, got it? And this here will be, let's say, yeah, this here will be change in y, delta y. This here will be change in x, delta x. Okay, so slope of the secant line will be what? Slope of the secant line will be what? Tell me, what will be the slope of the secant line? Is delta y over delta x. This is what the slope of that secant line will be. But you're not interested in the secant line. We're interested in finding the slope of the tangent line, which will be, the tangent line will be this, meaning delta x will go to 0. Does that make sense? Meaning this delta x goes to 0. Then what happens to the delta y? This is what you concern with. If the delta x goes to 0, then what happens to the delta y? And then we're gonna divide them. We're gonna find the ratio of delta y and delta x. So the limit of the derivative or the slope of the tangent line. So this is the tangent line. So the derivative is what? We do a derivative by this. So this is a big thing. Okay, so let me write it here. So the derivative, the formula to calculate derivative is fairly simple. It is this. We do it like this. F prime, let's say we are find it at x naught, the point at x naught. This will be limit delta x goes to 0, f of x naught plus delta x minus f of x naught divided by delta x. This is what the derivative. This is what the derivative is. It means this is the change in, a little change in what? This is delta x, meaning a little change in x. A little change in x. If you do a little change in x, what's the result? And that result minus the previous value, which is change in y. So this is nothing but the change in y. It means this is nothing but it is this. Limit delta x goes to 0, delta y over delta x. It is the same thing, delta y over delta x, but written in expanded form. Okay, written in terms of functions in expanded form. And this thing right over here is called the difference quotient. Difference quotient. This thing is called the difference quotient. And yeah, this is the formula for derivative. This is where the derivative of all the functions will come from. Does that make sense? And now there's also another formula which I would like to write it here. That formula will be, okay, f prime of x naught is equal to f of x, okay, minus, okay, so I should write with the limit as well. Limit x goes to x naught, f of x minus f of x naught divided by x minus x naught. This is the same thing. This is also the formula for the limit, for the derivative. Does that make sense? How this is also the formula? This is the value f of x, meaning the new value. This is the new value, and the new value is close to x naught. This is the previous value subtracted, so the new value is close to x naught, and then you divide the difference between the x. Does that make sense? So this is delta x, this is delta y. So this is also the formula, and this formula is written in terms of what? Delta x. I mean the delta x is going to 0. The difference in the x is a little nudge in the x. This is the formula. This formula is saying that. This formula is saying that your final value of x is close to the previous value, which actually is the same thing. And this also computes the derivative. This also computes the derivative. So keep both the formula in your mind. Both are gonna be useful. This was it in today's video.